let us start with the yesterday problem what I have given you in the homework. Some of you have done it correctly, but someone are still in confusion. So let me clear that confusion. This was a question u is given to you, and we have to find out the v, where fz is u plus iv is a analytic function. So first of all, what you have to do by Cauchy-Riemann first condition. So del u or del x will be equal to del v over del y. So u is differentiate this. So from here it will be 2x will be equal to del v over del y. Now we have to integrate it. Del v over del y is 2x. Now we have to integrate it. Now because integration is with respect to y. Understood? And we have to think the reverse also. While we were doing the differentiation of that, so that time you might have taken the x, because differentiation is with respect to y, that time you might have taken the, because it is a partial differentiation. In partial differentiation, other than y means x is there, so x function you have taken as constant. So that's why that I will add here extra. So first you integrate it. So then v will be 2xy and plus what I need to add? Fx. Some students are adding here fy. Okay, so here tell me if any confusion, please tell me. Because if I go reverse of that time what I have done, del v or del y, because this is a partial differentiation. So in partial differentiation, if there is a pure function of x, that I can treat as constant. So that's why that will become 0 here in the differentiation. So that's why when I am doing the integration, so that time I will add that function. Understood? Because in the partial differentiation, we consider the other function as constant. That's why. So this will be like this. Now this is my equation number 1. Again you apply CR second condition. In CR condition, del u or del y equals to minus del v or del x. Now here del u or del y will be minus 2y minus 1, and that is equal to minus of del v or del y, sorry, del x. Minus to minus will go. Now when we are integrating it again here, because differentiation is with respect to x, so that time you have taken fy, function of y you might have taken constant. So that's why fy we have to add extra when we integrate it. So del v over del x, sorry, by integrating it with respect to x, it will become 2xy plus x, sorry, plus fy. Two xy plus x and plus fy. So this will be the integration. You can match with your answers. Okay. Now this is your second equation. Now by comparing equation 1 and 2, okay, we are just comparing, and from both of them we will have a guess that which one is the correct answer. Okay, so because 2xy here is also there, 2xy here is also there, so this is common in both, so that will 100% come. So 2xy will 100% come. It is not like that you will add it, it will become 4xy. Some students have done that mistake also. Okay, this is the value of v. This is also the value of v. Here also I am writing the value of v, not anything extra. Just we have to compare from both the equation what will be the correct answer. So because this is also in that equation, this is also in that equation, so that will 100% come in that equation because it is common in both. Okay, plus what else should come? This fx is giving me clue that pure function of x should also be there. And when we check this in another equation, yes, it is there. So that also should be there. It has given me clue and it is available there. So I will take it. Now, second thing, fy is giving me clue that some pure function of y can also be there. Can or cannot be. Understood? It is just clue. But in another equation, there is no pure function of y. So I cannot take that. So that's why this much is the correct answer. Up to here only we have to stop. Some students are asking whether we have to add fx and fy. No, fx and fy are just function which will give you the clue. But in final answer, we will not take that. Understood? So now tell me if I need to explain it again or you understood. Okay? You note down it. So this is the final answer. So this way you have to find out, and every alternate exam this question comes. Note down it. Okay. Now there is one more way that you can find the fz directly. So that also I will tell. If you don't want to use that method, that is also not a problem. Means different methods are there, but sometimes that direct method will save your time. That's why I'm telling you to find fz directly from u or v. Okay, if u is known, okay, and actually this method is also named as, you understood now? Just you have to find out fz directly. Fz you want to find, fz is uxy plus ivxy. This I want to find directly. If any one of either u is given or v is given, this is our problem. Okay, this method is named as Milne-Thomson method. This method you have to use directly, you will find out. Okay, so first portion I am taking, if u is known. So if u is known, first you have to find out one function phi1, that will be nothing but ux. Ux means del u or del x. Take del u or del x, that will be phi1. And take phi2, that will be uy. Uy means del u or del y. So find del u or del x, del u or del y, name that phi1 and phi2. Okay, so directly you can say fz will be integral phi1 z0 dz minus I phi2 z0, this is 2 dz. So this method you can apply. By this method you can find out fz directly. Okay, no need to go so long. Means you will use first Cauchy-Riemann condition, then second Cauchy-Riemann condition, then you compare. Okay, this method is also applied if you want to have this method. Okay, So here actually what is phi1 z0? Because phi1 is function of x1 y, x and y. So get phi1 z0 from, because phi1 was function of xy. In place of x you write z, in place of y you write 0. So then you will get phi1 z0. Similarly, phi2 z0, you can find from phi2 is also function of, because here this is the function of xy. So in place of x you put z, in place of y you put 0. So then you will get phi2 z0. Then put in this equation. So this is suppose equation number 1. So in this equation directly you can put directly fz you can get. If v is asked to you, so what is the multiplication of this I? That will be v. Okay, so directly also you can do. Note down this. Done.
Sir.
Okay, so now next is if v is given. So if v is known, so then you have to find out psi1. Psi1 will be uy, because v is given, na? So vy. Psi1 will be vy, means del v or del y. And you have to find psi2. Psi2 is vx. So you can remember this is ux uy, this is vy vx, opposite to that. That will be del v or del x. Then directly fz will be integral psi1 z0 dz. Here in place of minus, plus sign is there, so that you have to remember. If v is given, psi2 z0 dz. So this will be the final answer. So quickly you can apply and you can put here, and from here you can find out v. Okay. So whichever method you are comfortable, you can use that. Okay. And similarly psi1 z0, that is similar. In place of x you put z, in place of y you put 0. So similar way you can find psi1 and psi2. Okay, so we can take one example to apply this method. Suppose u is given x cube minus 3xy square is real part of an analytic function okay, then find v is what? This is the question. So directly you find fz, and what is the component of I? That will become the, what is the imaginary component? That will become the v. So in this method, what I told you, first find phi1. Phi1 will be del u or del x. So del u or del x is 3x square minus 3y square Okay, so then you find phi 2. Phi 2 will be del u or del y. So del u or del y will be minus 6 xy. Okay, so now directly you can say because this is the phi 1 xy, this is phi 1 xy. I must written here, so I must have written here, this is psi 1 xy and this is psi 2 xy. Okay, so from here I will get psi 1 z0. Psi 1 z0 will be, in place of x you put z, in place of y you put 0. So this will become 3 z square. Now again psi 2 z0 will be 0. So now you can put, so your fz will be integral psi 1 z0 means 3z square dz square minus I into integral psi 2 z0, that is 0 dz. So just you can integrate it. So answer is 3 z cube by 3. Okay, and this is 0. So answer is z cube. So v value will be 0. Because function is having only real value. Sorry. Actually, this is z, and z we know that is x plus iy. Understood? That we have to put here because z is a complex function. So what I will do? Fz is z cube. Z cube means x plus iy whole cube. So that I have to open x cube plus iy whole cube plus 3x square into iy and plus 3x into iy whole square. So it will become x cube. This we have done earlier. Okay, so you can say x cube minus 3x square. So from here it will become minus 3x y square. That will be real part. Minus 3x y square. This is the real part, and plus I 3x square y minus y cube. This will be the imaginary part. So from here we can compare now. So this value will be u and this value will be v. Okay, so u is same. Sorry, this is u, no? So u is same and v is the this. So answer is v is equal to 3x square y minus y cube. So like this you can apply. If v is given, you can put in the second formula. Okay, so you can test it. So this is your homework. If v is known, suppose I am giving you the same question because it will be verified. Suppose v is 3x square y minus y cube. You know the answer that u should come. So u is what? So this is your homework. Okay, do it. Now you can note down it. Note down this page first. Done, sir. Okay. Now one more question I will tell you, because sometimes direct question comes, direct integrate you can do. just little bit knowledge of complex if you have, you can do that question. Okay, I will take one question, that is CSIR 2020 question. Okay, question was the value of closed integral dz by z, where C is a unit circle. Unit circle means radius of that circle is 1. With origin at its center. And integration is done in clockwise direction. Okay, so this fact I will tell you, whenever the integration is done in clockwise, you have to take negative sign. If the integration is done anti-clockwise, you have to take positive sign. Okay, so that I will write one statement in next part of this, but you can remember that. Otherwise, this is a simple integration question. Okay, looking difficult, but it is very, very simple. And the options are 2 pi I minus 2 pi I 0 I upon 2 pi. Okay, so the just complex knowledge you should have. What is the meaning of z? What is the meaning of dz? Okay, so we know z is how much? R e to the power I theta in polar coordinates. Okay, so that formula we can apply directly. This is e to the power I theta means cos I theta plus I sin theta. So that formula we have done already. Okay, so this is my z. So from here, if I want to find out dz, okay, so dz means differentiation I have to do here, and they have told already that your circle is the unit circle. Unit circle means radius is 1. So r is the radius now. So first we will apply that. Sorry. So for unit circle, r is equal to 1 means this is a circle with origin as its center. This is the origin, its center hai. Okay, so 1 is the r is equal to 1. This is a unit circle like this. So unit circle means, so then your z will be equal to e to the power I theta. So dz will be, just differentiate this side. So only theta is the variable. So it will become e to the power I theta into I, okay, into d theta. So dz will be converted to this and z will be converted to this. So now you can take your integral part. So closed integral dz by z can be written as, just put the value of dz, put the value of z. It will become closed integral. Closed integral means you have to start from one place and complete circle you have to integrate. But they have told that you have to integrate it clockwise. So clockwise direction, whatever the integral come, take that negative. That's it. This is the meaning of clockwise. This is clockwise. Okay. So dz value is e to the power I theta into I into d theta divided by z. Z means e to the power I theta. So this to this cancel. I will be taken common. And because I told you for clockwise direction, you have to take negative sign. That we can tell afterwards also, no problem. Just we are integrating it. So it is integral, closed integral. Closed integral always, because it is from here to here. Complete integral. It means what? Theta angle will vary 0 to 2 pi. So this you can write 0 to 2 pi. Closed integral can be converted to 0 to 2 pi. Understood? Because this will also, because in term of theta I want the limit. So that closed integral will give you the limit 0 to 2 pi. So I will come, so this is the d theta. So integral of this is I theta 0 to 2 pi. So answer is 2 pi I. So then we can say due to clockwise, that is also you have to apply, otherwise answer will be wrong and you will get negative marks, because both the answer are there. See here, 2 pi I, 2 pi are there. So due to clockwise direction, integral will be minus of 2 pi I. If it is anti-clockwise, then it would have become plus 2 pi I. Okay, so A is the correct answer. Note down this. So this is a very simple question, but giving you so much information. Okay, note down this. So this was about first variety of question. Which type of question come? This was first variety of question. Or you can say in the initial you can write first part of complex analysis. At the beginning only you can write this is the first part. So first type of question are like this. Now I will start second type of questions. Second part of complex analysis. So in second part, we will discuss about Taylor series, then Lorentz series, and residues. So we will talk about Taylor series, Lorentz series, and residues. Okay. So from here also question comes. So starting with Taylor series. So whenever Taylor series is there, I already told you that this is analytic in nature. So complete Taylor series is analytic series. This is also known as analytic series. Okay. Now, so what we want to do actually here? Suppose we have a function fz and we want to see the value of this function about some point. This point is z equal to z0. This is one point. Okay. So about this point, infinite number of points will be there around this. Okay. So for that, what is the value of function for all different number of points? These are infinite points. So what is the value of fz? So that will make a series, and that series is known as Taylor series. Okay. So we can write it. Suppose fz is a function and we want to see, or you want to write an infinite series. About a point z0. Okay. So this infinite series what is the specialty of this infinite series? This infinite series is close to, these are many points fz value at many points near to z0. So near to z0, so many points will be there. At all those points, I want to find out the value of function fz. So that fz function, if I add, so that will become a series. That series is known as infinite series. But that is near about a fixed point z0 only. Okay. Then we can write series as, so that series will be of the form fz equal to a naught plus a1 z minus z0 plus a2 z minus z0 whole square plus dot dot dot. So like this you will define this series. So this series is known as Lorentz series, sorry, Taylor series. Okay. In compact form also we can write it, means in summation. In compact form you can write fz will be summation n equal to 0 to infinity an z minus z0 to the power n. If you expand this, it will become that only. Okay, so note down it. Okay, now here this constant an, this constant an gives you the differential or derivatives of this function. This constant an is made up of derivatives of that function at point z0. Okay, you can say in Taylor series constant an is formed by derivative of fz, or you can say derivatives of fz at z0 point. Okay, so what I can write it? So an is f z0. In place of z you will write z0 and nth derivative. If you want to find an, so that will be nth derivative. If you want to find a1, that will be first derivative. If you want to find a0, that will be non-derivative. Divide by factorial n. So by this formula you can find out the an value. So here in Taylor series it is the derivative of that. So we can write the fz equal to summation n equal to 0 to infinity. So in place of an I can write this fz0 divided by factorial n to the power n. So this n give you the derivative. To remember it afterward, you write here that this is the derivative into z minus z0 to the power n. So this is the final compact form of Taylor series. Okay, this formula important, you remember. Or in expansion form also you can remember this. So these two formula are the final. Okay, now again, if you expand this now, because A1, A2, A3 value I have put here, it means that. So Taylor series will be Fz equals to, so in place of A0, what I will write, because that you have to use. Here it will be Fz0 only. That's it. Factorial 0 is 1 only. So that will be Fz0 plus. Next function will be F dash Z0 divided by factorial 1, that is 1 only, into Z minus Z0 to the power 1. This is second term. Number third, F double dash Z0 into Z minus Z0 whole square divided by factorial 2 and plus dot dot dot. So like this we can make the Taylor series. So these are so many form of Taylor series. You have to understand it, practice it, and whatever needed that you can use. Okay. So here, if this point, suppose sometime this point Z0, they tell that this is the origin only. Origin means 0. Okay. If Z0 equal to 0 point, 0 means Z0 equal to 0, that is, if point Z0 is 0, that is, it is origin. So that time, then this series will be named as Mach-Lorentz series. This series is called as, because this was given by Mach-Lorentz. In the same Taylor series, he had just put Z0 as 0. So then the new series came out, and that series is named as Mach-Lorentz series. Okay. And what it will become? Fz will be equal to, in place of Z0, just you put F0. So it will become F0 plus F dash 0 into Z minus 0 actually. So this will remain only Z. No need to write Z0. It will remain only Z. And plus F double dash 0 into Z square by factorial 2. This is factorial 2. Okay, plus third term will be into Z cube by factorial 3 plus dot dot dot. So like this we can write it. So this is the Mach-Lorentz series. Okay, note down it. Okay, now this Maclaurin series also I can have the compact form for Maclaurin series. Compact form will be fz equals to summation n equal to 0 to infinity. So I want to write this. So that will be fn 0, because in place of z0 it is 0 now. Divide by factorial n and into z to the power n. Okay. Now there was one more question. Use to get so many series now, we can use directly Maclaurin series. Use Maclaurin series to find series for fz equal to ln 1 plus z about z0 equal to 0 point, means about origin also they can say. Okay, so this series of ln 1 plus z I want to know about this. So whatever the series you want to know, so just follow this equation. So this equation is directly very important. For compact form also you can remember. Okay, so you can say by Maclaurin series, that series you write first and you can put the requirement of that series. Okay, your fz is f0 plus f dash 0 into z plus f double dash 0 into z square by factorial 2 plus f triple dash 0 z cube by factorial 3 plus dot dot dot. Okay, like this. So here what is my need? First I want to find f0. So directly fz is given. So f0 will be how much? ln 1. And what is the value of ln 1? 0. So this is your f0. Now you want to find f dash 0, but first I will find f dash z now. So in that I will put 0. So f dash z is, you differentiate it, that will be 1 upon 1 plus z. In that, so this implies f dash 0 will be 1 upon 1 plus 0. Answer is 1. Again you want to find, sorry. Okay, you note down this first. हेलो हाँ मैं 9 बजे करता हूँ कॉल ना डन yes sir okay so here I want now f double dash z so what is that double differentiation of that means single differentiation is this so differentiate it okay so that will give you it will be 1 plus z to the power minus 1 so minus 1 upon 1 plus z to the power 2 So that will become minus 1 divided by 1 plus z to the power 2. This is the double differentiation. So in that also I will put z equal to 0. So it will become f double dash 0 will become minus 1 upon 1 whole square. So answer is minus 1. Again I will find f triple dash z. So that will be minus 1 into minus 2. So that will be plus 2 divided by 1 plus z to the power 3. So from there you will find f triple dash 0 will be, just put 0, it is 2. Understood? So like this you will find. So now these values I will put in the series. This is my series. So from equation 1, fz will be f0 value is 0 only, plus f dash 0 is 1. So 1 into z, so that is z, and plus f double dash 0 is minus 1, na? So that will be minus of z square by 2. Factorial also you can solve. And this f triple dash 0, so that will be plus 2, na? But when you remove this factorial, it will become 3 into 2, and 2 to 2 will cancel. So that will become z cube by 3 and plus dot dot dot. So like this, this is the series for ln. This is the series for fz equal to ln 1 plus z. So ln 1 plus z is z minus z square by 2 plus z cube by 3, like this. You can proceed. Okay. So you can apply this method to find out any series. You can check it for example, some known also you know. So you can apply this method to known series. So then you will find some known Taylor series. You can apply Maclaurin. Okay. Suppose fz equal to e to the power z. So answer you already know, 1 plus z square by factorial 2 and plus dot dot dot. So you can apply that fz is e to the power z. Hello. Okay. One second. Okay. Second, you can check. Suppose fz equals to sine z. So that also we know z minus z cube by factorial 3 plus z to the power 5 by factorial 5 and minus dot dot dot. Fz equal to cos z is 1 minus z square by factorial 2 plus z to the power 4 by factorial 4 and minus dot dot dot. So like this infinite series we can have. Okay, and these series you must know, these series are about point z0 equal to 0, means they are about origin only. We remember them directly, but we must know these are about z0 equal to 0. If point has been changed, so then these are not the answer. So then that will be different. Okay. So that I will show you one example. how the answer will change. Understood? So note down this. Done?
Yes, sir.
Okay. Sometime you can get some series directly also by binomial theorem also you can use. Suppose I want to ask you the series for this. Series for 1 upon 1 minus z. Understood? So wisely you can use binomial expansion also. So this is 1 minus z to the power minus 1. Understood? So it will be direct 1 plus nx, so that will be 1 plus z plus z square plus dot dot dot, like this you can find out. This is about z0 equal to 0. So my question is, if point is other than z equals to 0, so then you have to find out the series. So for that also we have to learn the method how to find. Suppose this is the question, write series for fz equals to sin z about point z0 equal to pi by 4. Okay, here point is not 0, it is about z equals to pi by 4. Okay, so direct sin z series we cannot use. Remember here, direct sin z series can't be used because that is only for point z0 equal to 0. So here what you have to use, Maclaurin series you would not use because Maclaurin series is only for origin point. So here you have to use direct Taylor series. So by Taylor series, you know fz is fz0 plus f dash z0 z minus z0 to the power 1 divided by factorial 1 plus f double dash z0 z minus z0 to the power 2 divided by factorial 2 and plus dot dot dot. So here first you find fz0. Fz is how much? Sin z. So z0 is already pi by 4. So f pi by 4 is how much? Sin pi by 4. Sin pi by 4 is how much? 1 by root 2. Now you find f dash z. F dash z will be cos z. In that you put z equal to pi by 4. So f dash pi by 4 will be cos pi by 4 and that is also 1 by root 2. Similarly, you can find f double dash z, that will be minus of sin z, and from here you can find f double dash pi by 4, that will be minus of sin pi by 4, that will be minus 1 by root 2. So these value you can put here and directly you will get the answer. Okay, so series will be fz equals to sin z about that point. That will be fz0 is 1 by root 2 plus f dash z0 is also 1 by root 2 into z minus pi by 4 and plus minus 1 by root 2 z minus pi by 4 whole square divided by factorial 2 and plus dot dot dot. So like this you will get the series. So now you can understand what is the difference between the point. So direct series, whatever we know, those all are about origin. Note down this. And this was the question of NET 2019. They have just asked fz equal to sin z, and in the answer they have given that series. What is the direct series? Okay, so some student directly will tick that, but they have given the point is z0 equal to pi by 4. Okay, note down it. F triple dash also you can find out. So then that also will be minus of 1 by root 2. Minus of 1 by root 2 into then it will be z minus pi by 4 whole cube divided by 3 factorial. So that will be the series. F triple dash pi by 4, that also will be minus 1 by 2. Okay. Done.
So the sign is not changing alternate.
No, no, you can check here, na. If you want to find f triple dash, na, so minus is there, but sin z when it is converting to cos z, so cos pi by 4, so sign is same, because sign will depend upon this function, na, differentiation of that function. So function sin z differentiation will be converted to cos z, so no sign change. When cos z is converting to sin z, so after every 2 sign will change. So next step will be plus. Understood? Because sin z to cos z and cos z to sin z, when 2 differentiation are there, so for 2 differentiation sign will be same only. So from here to here it has changed. Any wrong in this?
Sir, here it's correct, sir, but how it's changing in the expansion about 0? It's alternate sign.
Because you can see here gap now, or you do it by Maclaurin series. then you will realize it. First you note down this, then we will do that. Done? It is done now?
Done, sir.
Okay. Fz equals to sin z.
Okay, sir. Sir, I got it. Sir.
You
Because
got it now?
Sin 0 is going to 0. So
Yes, yes, yes. Because one term will be gap. So you do it. I told you, you check it. Understood? It is your homework. Now, many times we will use binomial expansion. So I'm writing the formula. Otherwise, you have to search some 12th book. So binomial series. There is one formula. Suppose it is 1 plus x to the power n. This will be mostly used. So that will be 1 plus nx plus n into n minus 1 divided by factorial 2 x square, and plus n into n minus 1 into n minus 2 divided by factorial 3 x cube. So like this it will go. If it is minus 1 minus x to the power minus n, so then it will be 1 plus nx, but here wherever we are using minus minus, we will use plus plus. So then it will be n plus 1 divided by factorial 2 x square plus n into n plus 1 into n plus 2 divided by factorial 3 x cube. And same thing I have used when I was using 1 minus z to the power minus 1. 1 upon 1 minus z. Okay, so for to find out that series, if I want to find out that here n is 1, so that you put in this equation, so that will become 1 plus n is 1, so z, and plus n into n plus 1 means 2 divided by factorial 2, so that is also 1, so that will become z square. Here 1 into 2 into 3, so that is a factorial 3, so factorial 3 by factorial 3 1, so answer is z cube. So that's why I have used this equation. Okay, so these two formula you must remember. Note down this. Done?
Done, sir.
Okay. Next thing is the radius of convergence. Radius of convergence means, from the name itself, we want to know the radius of a circle, in which circle my whole series is converging. Understood? If this is a circle, in that circle my complete series will finish or converge. So that circle radius is how much, that I want to know. Okay, so this is the radius of a circle inside which the series is converging. The series Fz is converging. Okay, and that can be find out, that radius can be find out, limit n tending to infinity mod of an divided by an plus 1. An is Taylor series constant. Okay, you do the Taylor expansion of that function and then you can find it. Suppose I take example, if fz function is given you like this, summation n equal to 0 to infinity z minus I to the power n divided by 1 minus I to the power n plus 1. Okay, so this is the series. So this is like z minus z0 to the power n, and whatever left, that will be the an if you compare it from Taylor series. Okay, by this is the compact form of Taylor series. You can compare it from there by comparing with Taylor series. So an will be how much? An will be 1 upon 1 minus I to the power n plus 1. Okay, so an plus 1 will be what? In place of n you put n plus 1. An plus 1 will become 1 upon 1 minus I to the power n plus 2. And what you want to find out? You want to find out radius. So radius of convergence of fz will be r equal to limit n tending to infinity mod of an divided by this. If you can divide it, so that will be mod of 1 minus I. Okay, so no need to take n now. This is 1 minus I only, no n is there. You differentiate means take the ratio of this. So this will be 1 minus I to the power n plus 2. This is 1 minus I to the power n plus 1. So n plus 1 power will cut and 1 minus I is left. Now mod of this is how much? Under root of 1 plus 1. Answer is under root of 2. It means what? It means what? This value is under root 2. So this is the radius of convergence. It is telling you that all the series points are inside this radius only. All the series will be converging to this, or you can say all the series is limited to this circle only. Okay, if you want to say it circle, but if you consider the points also in between point also, so then this will become like a disk. So this is also named as disk of convergence. Convergence. Disk of convergence. Okay, with radius under root 2. Okay, now because my point, if you take the point, this is about point I. So point is not the origin. Your point is I. Understood? Your point is I. If I draw the, because I is on the imaginary, if I draw the argand plane here, so this is your imaginary axis, and somewhere here, or because I is magnitude of I is 1 and this magnitude radius is under root 2. So actually here will be the second axis. So this is your real axis. This is your imaginary axis, and here will be the origin. Origin has been taken at pi. So radius can be written as, radius always can be written as z minus I. Okay, but value is under root 2. So here z minus I is, this implies z minus I mod of that is equal to under root 2. So this is the answer. Note down it. Here I is the origin of circle. Done.
Yes, sir.
Okay. Actually, we have made the circle only. For that only we are finding out the radius. But including all these points, we can call it disk. Okay. So I will give you. Sometime they can ask you what is about disk. So no need to confusion. So this is set. The set of all points which are inside this circle means all points for radius are less than under root 2. So these are inside point only. So from this it is clear. The set of all points which are their radius is less than under root 2 is called disk of convergence. Okay, so this is finished. Now let us talk about Lorentz series. So for Lorentz series, we can directly write it. Fz is the Lorentz series will contain first Taylor series. After that, some addition to that. So A0 plus A1 Z minus Z0 plus A2 Z minus Z0 whole square and plus dot dot dot. So this is the Taylor part, and in that addition to that there will be B1 divided by Z minus Z0 plus B2 divided by Z minus Z0 whole square plus B3 divided by Z minus Z0 whole cube and plus dot dot dot. Here you can notice one thing, that here power 0 is starting, but here power 1 is starting, because power 0 will not be there. Okay. So here this part of Lorentz series is known as principal part, because only due to this part it is named as Lorentz series. Otherwise this portion is the Taylor series. Okay, this portion is the Taylor series and this part is known as analytic part, because Taylor series is always analytic in nature. So this part is the analytic part and this part is the principal part or non-analytic part. Everything of this you should understand. Okay. In compact form, how I can write this Lorentz series? Fz will be, this will be same, summation n equal to 0 to infinity an z minus z0 to the power n plus summation n equal to 1 to infinity. This you have to mind. It will be bn divided by z minus z0 to the power n. So this is the compact form of this series. Okay, note down this.
When, sir?
Okay, so next next heading is the residue. Taylor series over, Lorentz series over, the now residue of Fz. Okay, one more thing I should tell there that I forgot. See here, if I put Z equal to Z0 at Z equal to Z0, if I put Z equal to Z0, so this will become 0. So B1 divided by 0 will become infinity, and whatever you add in the infinity, that will be infinity only. So then Fz is infinity, that is function is not defined. At Z equal to Z0, and so it is known as singularity. It is named as singularity. Singularity or pole are the point where function is not defined. Okay, so it is known as, or you can say Z equal to Z, or it is known as singular point. Okay, and what is the meaning of that? That function is not defined means that is function is non-analytic. Non-analytic at Z equal to Z0. So these are the some outcome of this. So this also you must remember. Now you can put the heading residue. Residue at, residue of Fz at Z equal to Z0. Okay, so what will be residue, that I will tell you at the final time, but actually in Lorentz series now, in Lorentz series, this portion is very, very important because this will give you the residue. So coefficient of 1 upon z minus z0 to the power 1, you can say coefficient of 1 upon z minus z0 will give you the residue. So what is residue? B1 value is the residue. So whatever the function given to you, you just find Lorentz series of that. In that Lorentz series, the coefficient of 1 upon z minus z0 is the residue. That's it. Means first part of the principal, first term of the principal part will give you the residue. So directly you can say, we will do so many example of that, then you can understand. So directly definition you can write in Lorentz series. The coefficient of 1 upon z minus z0 is known as residue. Residue of fz at z equals to z0. That is what is here coefficient? Here coefficient is b1. That is b1 is known as residue. Very simple. You can take it directly. So Lorentz series you can find out by Taylor series method or binomial method. Lorentz series can be find out wisely by binomial method or Taylor expansion method. Okay, by any way you can find it out. Now we have seen that the coefficients in Taylor series were a1, a2, a3 like this. Understood? And in principal part of Lorentz series, coefficients are b1, b2, b3 like this. Okay, because b1, b2, b3 are principal part coefficients, and here they give you the integral form, or you can say that they are formed by integration of the function. They are formed by, you can say, the coefficients of Lorentz series. Lorentz series means we are talking about principal part only. Coefficients of Lorentz series are formed by integral of function fz. Okay, but there in the Taylor series, these coefficients are made by differentiation of the function, but here they are made by integral of the function. Okay, so these can be utilized to get complex integral, because they are made by integral of the function. So these coefficient can be utilized to get the integral of the function. Simple. Note down it.
Sir.
Okay. So if I write the Lorentz series, so what is the Lorentz series? Fz equal to summation n equal to 0 to infinity an z minus z0 to the power n plus summation n equal to 1 to infinity bn divided by z minus z0 to the power n. So this is the Lorentz series. Okay, this is the principal part. Or non-analytic part, and this is the analytic part. Okay, now here bn we have to define now. Bn is equal to 1 upon 2 pi I. It is made by integral of fz. So integral of fz divided by z minus z0 to the power minus n plus 1. This is the formula of bn. So here bn will be this much dz. Okay, and n value can be 1, 2, 3, like here n value are starting from 1, not from 0. Okay, so because I want to find residue, so residue will be equal to b1, and b1 means you have to put n equal to 1. So put here n equal to 1, it will be z minus z0 to the power minus 1 plus 1 is 0. So power of that is 1. So it means the answer is 1 upon 2 pi I close integral fz divided by, so not divided by, it is 1 only, dz. Understood? So from here we get a clue that suppose if you want to know the integral of any function, and that integral is very difficult to find out by us, so then what you can use? So that will be given by 2 pi I multiplied by residue. So this has become a new formula, and that is very important formula. Okay, because just 2 pi I into residue directly you can check from the series. What is residue? That is the coefficient of the 1 upon z minus z0. Directly you put in this formula, you will find out the integral. Let it be so much difficult integral, but by this method, if you know the Lorentz series of that fz, so from that you find the b1. b1 is the coefficient of 1 upon 1 z minus z0. You find that, just multiply with 2 pi I. Okay, if there are so many residue, means if there are so many singular points, suppose this is a suppose this function is like this, fz is 1 upon z minus 4 into z minus 2. So this is also singularity, this is also singularity. In that case, you will get one residue R1 and other residue R2. Okay, because about point this you will get different series, about point z equal to 2 you will get different series, and in that you will get b1, here also you will get b1. So those will give you 2 residue. So that time, in place of taking single residue, you have to take summation of residue. So in general we can say that, in general, if so many residue are there, because so many points are there, so many singular points are there or poles are there, so for that, in general, close integral, this is the close integral. So C also we can write here, Fz dz will be 2 pi I into summation of residue. So in general, this is the final formula, and this formula is known as Cauchy integral formula. Cauchy integral formula. Okay, so very simple to find out the integral now. Just find out the residue. If so many residue, just take summation of that into 2 pi I. Then you will get the answer. Note down it.
Then, sir.
Okay. Now, so these are just basic we are developing. Otherwise, we will do the numericals separately. And one more thing you must know: how many type of singularities we are dealing with. Singularity. So, what is the singularity? These are points where function is not defined. Function fz is not defined. Not defined or non-analytic. Not analytic. Not defined, or you can say not analytic. So all such points are known as singularity. Simple definition. Okay, we have seen it. If you put that point in that function, so function will become infinite. It means it is not defined. So this means to say, okay. So there are so many type of singularity. Number one, if only B1 is present. B1 means only one component, first term of principal part of Lorentz series is only present. So if only B1 is present in Lorentz series of Fz, okay, then point Z0 is a pole of order 1. Means only one pole is one singularity is there, so single singularity is known as pole. Okay, so then Z0 is a pole of order 1. If for the same point there is power is given, power 2, power 3, power 4, so then order will become 2, 3, 4 like this. Okay, so B1 means order is 1 only and power is also 1 only. So this is the meaning of that, because we know that Bn is 1 upon Z minus Z0 to the power n. Coefficient of that is the Bn. Coefficient of that, or you can say complete term will be like this. So if only B1 is there, so that power also will be 1, and it means what? So this is a pole and power is 1, so that will be single power pole. Understood? Or pole of order 1. If it is B2, so then it will be 2. So it will be pole of order 2. If it is N, it will be N. So that will be pole of order N. So like this, it will increase depending upon value of N. So it is saying that if only B1 is present, means this N value is 1. So then pole also will be of order 1. Okay. Or pole of order 1 is also named as simple pole. Simple pole. So this is also the name of pole of order 1. Number B condition. If Bn is present, it means in the denominator there is z minus z0 to the power n. So then z0 is pole of order n. This is the meaning of that. So if Bn is present means this complete term is present. So then z0 will be pole of order n. So you can write here, if Bn is present, then z0 is pole of order n. Okay, and with that actually n minus 1 term, n minus 2 term, or B1 term, those also can be present, but we will see the highest term. So from that highest term we will find out the pole order. Understood? So we can write here, and before term also may be there, but this is the highest term. Highest term will decide the pole of how much order. Before terms also can be or cannot be present. Can be present. Understood? So like this you will decide the order of pole. Number third condition is that if there are infinite terms, means n tending to infinity, infinite terms means your n is tending to infinity, then, but for what? For principal part only I am talking. If there are infinite terms Bn n tending to infinity, so I am talking about Bn. Bn means it will give you the principal part. So infinite term of Bn are there, then it is known as essential singularity. So z equal to z naught, then z equal to z naught is known as essential singularity. Okay, and if it is not infinite, so then also can be named as, because that can be named as that also, simple pole or pole of order something, or it can be also known as non-essential singularity. So two names can be there, but on this definition we can say that for finite terms, Bn, z equal to z naught is known as non-essential singularity, also can be given the name. So in some options you can find out non-essential singularity. So meaning of that is your n is finite here. So finite term of Bn are there. Okay, note down it. Done?
Yes, sir.
Okay. D point. Suppose I draw a circle. If this is a circle, I am drawing this circle. This is my point Z0. About this point, I am drawing a circle of radius epsilon. Okay. If this is a circle of radius epsilon, and epsilon is very small, of radius epsilon tending to 0, means this is very small circle. Actually I should have made it like this, but it will not be visible whatever I'm saying here, so that's why I made it like this. So this is a circle of radius epsilon tending to 0, such that no other singularity lies inside this circle. Okay, then Z0, because only one singularity is there, and nearby to this no other singularity are there. Singularity can be here outside to this, other singularity can be outside to this, but inside this no singularity is there. Understood? So such, then Z0 is known as isolated singularity. Means it is like the discrete thing, it is not connected to anyone, so it is isolated, separated from other singularity, that is known as isolated singularity. So then Z0 is known as isolated singularity. So meaning of that is that nearby to Z0 no other singularity is available, so then Z0 is isolated from other singularity. So this is the meaning of that. Okay, E thing, E point, if same definition I'm writing, this point is Z0. If this is a circle of radius epsilon tending to 0, such that other singularity also lies. Either many singularity or single singularity. Other singularity, suppose Z dash, also lies inside this circle, means it is nearby to Z0 only, means in nearby to any singularity, if one more or many more singularities are there, so this is the condition of that. Okay, other singularity Z0 also lies inside the circle, then Z equals to Z0 is known as non-isolated singularity. So these names also sometimes you have to recognize. Conditions will be given. So these conditions are matching with this, so then you have to name them accordingly. Non-isolated singularity. Understood? So here I have to make in this circle some Z1 is also there, or Z dash you put. There may be so many Z2, Z3, Z, okay, but at least one is there. If at least one is there, so then the definition of Z0 will be different. So Z equal to Z0 will be known as non-isolated singularity. Okay, note down it. Done?
Yes, sir.
Okay. So if I'm giving you one question, for a function fz equal to 1 upon z minus 1 into z minus 2, find the types of singularity. Okay, so this is the function. First of all, because here 2 points can be there for singularity. If I put z equal to 1, so that is also a singularity. If I put z equal to 2, that is also a singularity. Because putting z equal to 2, that will become 0, it is infinite. Again, putting z equal to 1, that is also infinite. Understood? So here 2, you can say these are two singularity, or these are two poles. And what is the power of that? Because z minus 1 to the power 1, so that is a simple pole. Z minus 2 to the power 1, that is also a simple pole. Okay, so we can say here at z equal to 1 and at z equal to 2, function is not defined. So z equal to 1 and z equal to 2 are two simple poles. Simple pole or pole of order 1. Simple poles or poles of order 1, because both will have order 1. If it is power 2, so then z equal to 2 will be pole of order 2 and z equal to 1 will be pole of order 1. But it is here given only power 1. So that's why both are simple pole. So first of all, that name I have given. So maximum name I want to give, how much I can give. Now you can check. Suppose this is a z line. On that line, the z equal to 1 will be this point. Z equal to 2 will be this point. Now I want to check whether these singularities are isolated or non-isolated. Because I told that about this pole, you have to draw a circle. That circle should be very small. So whether this another pole coming into this? No. Again, you draw a circle about this point. The other pole is coming into this? No. So that's why these are also named as non-isolated singularity. Understood? Z equal to 1 and Z equal to 2 are also known as isolated singularity. They are also known as simple pole. They are also known as isolated singularity. So many name can be there. If it is there, so then it is also true. If it is there, that is also true. Okay, so like this you can do it. Note down it. Done?
Yes, sir.
Okay. One more question I will take for this. For function fz equal to 1 upon sine pi by z. Find type of singularity. So this is the question. So here again, to find the singularity or pole, I can put this equal to 0. Put sine pi by z equal to 0 to find out the pole. Actually, to find out the singularity or pole, we put it equal to 0. So here also actually denominator you put equal to 0. Put z minus 1 into z minus 2 equal to 0. So from that I got that z is equal to 1 also, z equal to 2 also. Understood? So this is my method. Whatever the denominator, put equal to 0 to find out the pole or singularity. So here also put denominator equal to 0. This is the denominator. So put denominator equal to 0. So now it will be sine pi by z. So right hand side also I can convert in sine form. I can write it sine n pi. Now comparing on both sides, it will give me pi by z equal to n pi. Pi to pi cancel. Okay. So z will be, because I want to find out pole, z is 1 by n. Now n can be any number. So n can be 1, 2, 3, 4, 5, 6 like this. So it can be increasing. So your z means there are so many singularities. So many singularity are there depending upon n value. So singularities also will be 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, 1 by 8 like this. Okay. But now this is the suppose z line. On that z line you want to draw them. So this is the origin. So z equal to 1 is this point. After that 1 by 2 is quite far. After that 1 by 3 it is nearby. 1 by 4 more nearby. Then 1 by 5. Then 1 by 6. Okay. Once we are going at higher value of n, so all the points are clubbing together. So once it is 1 by 100, 1 by 101, 1 by 102. Once you reach there, you will find that these points are very, very nearby. So here, these points are very, very nearby. So if I draw a circle to here, so other point also will lie here. Understood? 100, suppose I am saying that it is for z0 equal to 100. So in that circle only, if you put a circle about z0 equal to 100, so in that only z dash equal to 101 also will lie. Sorry, 1 by 100. Then 1 by 101 will also lie. Understood? So it means these singularity are known as non-isolated singularity. But if you draw here circle, no nearby there, So this is also known as isolated singularity. So this is a combination of isolated singularity and non-isolated singularity. So this is the isolated, and here nearby to 0, these are non-isolated. So we will not give this answer like isolated or that. We will say that these contains the non-isolated singularity. So we can say that fz equal to 1 upon sine pi by z has. So this has non-isolated singularity. Okay, and some singularity are isolated also, but because this is the main thing what we want to say, so this is the final answer for that. Note down it. So understood how to decide the singularity is isolated or non-isolated. So this is the example of non-isolated singularity. Done?
Sir, and the series have infinite terms also.
Yes. Because it is n pi, na? It is n pi. So we can have infinite number. So infinite singularity are there. Yes, it is infinite. It is infinite terms, na? So you can say that this series will have essential singularity. So it is also named as essential singularity. So this is also another name. So we have to check in the option what he is asking. So accordingly we can give the answer. Okay, so this is all for